Refrigeration HVAC exam practice questions set number 8. Number 1. How do you adjust the overload on a motor starter? Check the nameplate full load amperage FLA and blank it with the correct service factor multiplier of the motor. A. Add, B. Subtract, C. Multiply, D. Divide. Correct answer is C. Multiply. So below is the explanation. How to size the motor overload protection device. For SF or service factors greater than 1.15, the overload amperage OLA is equal to full load amperage FLA times 1.25. For service factors equal to 1.15, overload amperage is equal to full load amperage times 1.25. So same formula for greater than and equal to. But for service factors lesser than 1.15, the formula is different. Overload amperage equals full load amperage times 1.15. Okay, so the definitions are SF service factor, FLA full load amperage or full load current, OLA overload amperage maximum for the overload protection device. So examples of overload protection devices include fuses, circuit breakers, motor starters with overload relays, or solid state motor controller or starter. So example number 1. So there are 3 examples here that I will discuss. One is equal to 1.15 service factor, one is with service factor greater than 1.15, and one that has a service factor lesser than 1.15. Example number 1, this is the one that has service factor equal to 1.15. So the nameplate of a continuous duty motor has a service factor of 1.15 and a full load amperage of 20 amps. Calculate the size of the overload protection device. Analyzing the given, we have service factor 1.15, full load amperage 20 amps. And the formula that I discussed above is for a service factor equal to 1.15, the overload amperage is equal to full load amperage times 1.25. So the overload protection device size is equal to 20 times 1.25. 20 was given, 20 amps. So overload amperage is equal to 20 times 1.25 is equal to 25 amperes. That's the size of the overload protection device, 25 amps. Example number 2. This is the one that has a service factor greater than 1.15. So the nameplate of a continuous duty motor has a service factor of 1.30 and a full load current of 32 amps. Calculate the size of the overload protection device. So the given 1.30 service factor and 32 amps full load amperage, full load current. The full formula for OLA, overload amps, is equal to full load amps times 1.25, because the service factor is 1.3. This is greater than 1.15, so we use the formula OLA is equal to FLA times 1.25. So substituting the given, got 32 amps full load amps. The overload size will be 32 times 1.25 is equal to 40 amps. It's the size of the overload protection device. Sample number 3 is where we have a full load service factor of 1.10, and this is lesser than 1.15. Nameplate of a continuous duty motor has a service factor of 1.10 and a full load current of 17.3 amps. Determine the size of the overload protection device. So here's our given: 1.10 service factor and a full load amps of 17.3. So then in this case we have a service factor lesser than 1.15, and therefore we use the formula overload amps is equal to full load amps times 1.15. So the given full load amps is 17.3. So we substitute in the equation. Overload amps is equal to 17.3 times 1.15, and we got OLA as 20 amps, and that's the size of the overload protection device. Okay, so 3 examples covering 3 scenarios: equal, greater, and lesser than 1.15 service factor. Okay, number 2. When the temperature of water entering in is equal to the temperature of water leaving out, the inlet guide vanes in a centrifugal chiller is at blank: 25%, 50%, 75%, or 100%. Correct answer is B, 50%. Number 3. The location of the pressure line of a fan control is A, suction line; B, inlet line; C, equalizer line; D, discharge line. Correct answer is D, discharge line. Number 4. When a refrigeration system with a capillary tube metering device is overfeeding the evaporator, the remedy is to recover the refrigerant, weigh it, and remove some refrigerant. A, true; B, false. Correct answer is A, true. Note: a capillary tube system is critically charged, meaning the amount of refrigerant is just right, exact amount, not too much, not too little. Number 5. An R134A refrigerated box temperature, cut-in temperature is 38 Fahrenheit and the differential is 3 Fahrenheit. Determine the cutout pressure. A. 20 psig, B. 25 psig, C. 30 psig, D. 35 psig. Correct answer is C. 30 psig. And the solution is given below. So the given, we have a cut-in temperature of 38 Fahrenheit and a differential of 3 Fahrenheit. The solution is to determine the cutout temperature by subtracting the cut-in temperature cutout temperature is equal to cut-in temperature minus differential. So we wanted to calculate the cutout temperature, and then once we determine the cutout temperature, we'll determine the corresponding pressure with that temperature. Okay, so need to find out the cutout temperature, and we can do this by taking a look at our given. We are given cut-in of 38 and a differential of 3 Fahrenheit. So to find out the cutout temperature, we just needed to subtract 38 minus 3, we get 35 Fahrenheit. So that's the cutout temperature. And then using a pressure temperature chart, PT chart, and looking at R134A, we find out that the cutout pressure at 35 Fahrenheit is equal to 30 psig. And the cutout pressure is the pressure at which the compressor stops. Number 6. A chilled water system has excessive amount of calcium and magnesium. How do you fix this? A. Decrease flush rate. B. Increase flush rate or blow down. C. Shut blow down valve. D. Maintain valve opening. Correct answer is B. Increase flush rate or blow down. Number 7. The main advantage or benefit of a pump down system is that it prevents the migration of refrigerant into the compressor crankcase. A. True. B. False. Correct answer is A. True. In a pump down refrigeration system, the refrigerant is pumped down into the condenser and liquid receiver, high side of the system, thereby isolating the refrigerant from the low side of the system when the compressor is off. Number 8. The cutout setting of low temperature freezers using R502 or R404A should be set lower than 0 psig. A. True. B. False. Correct answer is B. False. The reason being is that cutout settings that result in a vacuum must be avoided in order to prevent air or other non-condensable gases from entering the system. Number 9. In a low pressure control, the cut-in is the pressure in which the compressor blank starts. A. B. Stops. C. Run continuously. Correct answer is A. Starts. Number 10. Coil TD, coil temperature difference, is the temperature difference between the box temperature and the refrigerant temperature in the blank condenser coil, compressor, evaporator coil, or liquid receiver. Correct answer is C. Evaporator coil. Evaporator coil. Letter C. Typical design coil TD for walk-in coolers is from 10 Fahrenheit to 15 Fahrenheit. For freezers, design coil TD is 10 Fahrenheit. Number 11. If the differential pressure used for operating the compressor is too short, it will not cause short cycling. A. True. B. False. Correct answer is B. False. A differential setting too low or too short will cause short cycling of compressor. Differential setting too high or too long will create wide temperature swings or temperature variations, which can lead to compressor motor overheating. Number 12. If refrigeration and air conditioning units in low ambient conditions using fan cycling for head pressure control have too small fan differential pressure, it will cause the TXV to blank. A. Hunt. B. Equalize. C. Open. D. Close. Correct answer is A. Hunt. If the condenser fan differential pressure is too small, it will cause short cycling of the condenser fan motor and increase wear and tear, and it will shorten the life of the motor. If the differential is too big, it will create big head pressure fluctuations, causing the TXV metering device to hunt. Okay, that's it for this question set. I'll see you in the next video. Cheers and take care.